In this video, we're going to talk about replacement. If we are drawing something from a bag or from a deck of cards, there's really two possibilities for how it could be done. We could do without replacement or with replacement. If we are drawing without replacement, then that means that when something is drawn, it is not put back before the next draw. So our total number of objects in the set is decreasing because whatever we're taking out, we're not putting back in. If we do with replacement, that means that when something is drawn, it is put back before the next draw. So our total number of objects is not changing from draw to draw. We always have the same amount of things in the set. So we have a box here that contains 3 red and 5 white balls. What is the probability of drawing a white ball? So I have 5 white balls out of 8 total balls. So the probability of drawing white is 5/8. Now we're going to complete the tree diagram to calculate the probability of each result if 2 balls are drawn in succession without replacement. So on our first draw, we could get red or white. The probability of getting white is 5/8, and the probability of getting red is 3/8 because there are 3 red balls with 8 total balls. Now, if we're doing this without replacement, that means that whatever we get on the first draw, we are removing from the box before we do the second draw. So if our first ball is red, then we remove that ball from the box. And so what is left in the box is 2 red balls and 5 white balls. So our probability of getting red on the second ball is going to be 2/7. And our probability of white is going to be 5/7. Because there are 7 total balls left, 2 of them are red and 5 of them are white. If our first ball is a white ball, then that means that what is left in the box is 3 red and 4 white balls. So the probability of drawing a red on the second draw is 3/7. And the probability of drawing a white is 4/7, because there are 3 red and 4 white balls left, so 7 total balls. Now we can find the probability of each combination here. So the probability that the first is red and the second is red is 3/8 times 2/7. And again, remember how we multiply fractions here. We are multiplying the numerators. 3 times 2 is 6. Multiplying the denominators, 8 times 7 is 56. And then we probably will need to simplify that to 3/28. For the second one here, the probability that the first is red and the second is white, that's going to be 3/8 times 5/7. Which is 15 over 56. Here we have 5/8 times 3/7, which is also 15/56. And finally, the probability that they are both white is 5/8 times 4/7, Five times 4 is 20, so that's 20 over 56. Question 3 says, based on the results above, is the probability of drawing a white ball on your second draw affected by what happened on the first draw? And so let's compare our 2 probabilities of getting a white ball on the second draw. This is the probability if the first ball was white is 4/7. If the first ball was red, then the probability of getting white on the second draw is 5/7. So these are different probabilities. So that means that yes, the probability of drawing a white ball was affected by what happened on the first draw. If we got red on the first draw, then we are more likely to get white on the second draw. And that should make sense because if we drew a white ball first and removed it, then that means that there are fewer white balls that I could get on the second draw. If the first ball that I removed was red, then I still have all of my white balls left that I could choose on my second draw. Now, for question 4, we are completing the tree diagram if we are doing with replacement. So now we are replacing the ball every time that we draw before we do the second draw. So I still have my same first 2 probabilities here because I have 3 red balls and 5 white balls. So the probability that I get red on the first draw is 3/8, and the probability that I get white is 5/8. Now, I'm putting that red ball back in the box before I draw my second ball. So that means the probability that the second ball is red is still going to be 3/8 because I still have 3 red and 5 white in the box. And the probability of white on the second is still 5/8. And it's the same whether the first ball is red or the first ball is white because I always have 3 red balls and 5 white balls in the box. So these probabilities are both 3/8 and 5/8. Now I can get my probabilities here again by multiplying. So the probability that they are both red is going to be 3/8 times 3/8. And if I multiply that, I get 9/64. The probability that the first is red and the second is white is going to be 3/8 times 5/8, which is 15/64. The probability that the first is white and the second is red is 5/8 times 3/8, also 15/64. And finally, the probability of white and white for both, is 5/8 times 5/8, which is 25/64. And finally, for question 5, it says, based on the results above, is the probability of drawing a white ball on your second draw affected by what happened on the first draw? And the answer to that is no, because my probability of drawing white is always 5/8. Since I'm putting that first ball back into the box before I do my second draw, it does not matter whether I got white or red on the first one. My probability is always going to be 5/8 because I am putting that back into the box. And so I always have 5 white out of 8 total balls. So the answer here is no. Since you are putting the ball back before the second draw, the probability of white is always 5/8.